FDP on insights into cutting-edge technologies. It's my proud privilege to invite our today's speaker, Mr. Vinay Varne, Application Engineer, Grundfos, Pumps India Private Limited from New Delhi, and our Head of the Department, Dr. A. Chelambuchelvan sir, and our Coordinator, Mrs. N. Padmavati Madam, faculty members, research scholars from different parts, different parts of the country and across the globe. Okay, sir, I request our Head of the Department, sir, to introduce Mr. Vinay Varne to the gathering, sir. Over to you, sir.
Thank you, ma'am. Good afternoon, all. I welcome you all for the Faculty Development Program on Insight into the Cutting Edge Technology for the day, organized by the Department of Electronics and Instrumentation Engineering of R.M.D. Engineering College. The resource person of today's session, Mr. Vinay Varne, Application Manager, Grundfos Pumps India, New Delhi, is going to deliver the topic on Building Management System. It gives me great pleasure to introduce Mr. Vinay Varne. Mr. Vinay completed Bachelor's of Engineering degree in Electronics Engineering in the year 2004 and postgraduate diploma in Energy Management in the year 2019. Vinay currently working as Application Manager for Grundfos Pumps India. Functionally, he works in commercialized building service team in Grundfos Pumps headquarters in Denmark. He previously worked 11 years as Principal Engineer for BMS Controls in Johnson Controls. He played different roles as Application Engineer, Quality and Competence Manager, Engineering Manager, Business Analysis, Commissioning Engineer, System Engineer, etc. Before Johnson Controls, he worked with Mason and Mitsubishi for 3 years for PLC, HMI, Servo Motion, Controls applications in India. He worked in United States of America for 4 years on sites for HVAC controls as well as commissioned redundant data center chiller water plant for Bank of Mexico, Citibank Group in Mexico. He established BMS lab from Johnson Controls in D.Y. Patel College, Pune and R.M.D. Engineering College in Chennai. Training visits for PLC BMS customers as a trainer for Procter & Gamble Goa, SKF Bearing India Limited Pune, Cummins India Limited Pune, Johnson Controls USA branches for system engineers and system technicians. Vinay has US patents approved water plant optimizer for member of ASRE and ISRE, total 16 years of experience in BMS, PLC, EMS, HVAC, control system industry. We are delighted to have an expert for this session. So on behalf of Electronics and Instrumentation Department and my own behalf, I welcome Vinay. Now I request Mr. Vinay to take over the session. Please, sir. Mr. Vinay.
Yeah, thank you, sir. Thanks for the introduction, and it is a great pleasure to be here presenting for R.M.D. College and explore my knowledge on BMS. Thanks to Nalina Madam and Chelambu sir for the encouragement, and absolutely R.M.D. RMK College. I visited a number of times there and I established lab as it. So let's start the session, okay? And let me share my screen first. I think everybody can see my screen, correct? Yeah, ma'am, can you able to see my screen?
Yes, sir.
Should I go ahead?
Yes, sir.
Okay, thank you. So today's topic is building an energy management system. Okay, and really interesting topic. Something is a mix of electronics, mechanical engineering, electronics, as well as computer science, data science, and everything has been integrated. And that's why I made it something like building an energy management system. Okay, so 4 things I want to cover in next 1 hour session. So it will be a little bit lengthy of 1 hour, but please bear with me because there are a lot of things I want to teach you. I just want to touch base few basic concepts and then maybe you can call me back or email me, or you can find out your own resources like Google to get more information in those particular topics. So 4 topics I'm going to cover today is the BMS basics, then EMS, energy management system, and we are going to talk about the CPO, center plant optimizer. The project Haystack, a little bit, I want to touch base with the IoT. And the last one is the EMS software, the Copper Tree. Copper Tree is the name of the organization, and I'm going to show you or demonstrate you how the EMS software look like, because this is my current project which I'm working with the US and Denmark branch in my job profile. So I'm just excited to talk about how the software look like, what are the energy saving opportunities and all that. Okay, so as I mentioned here, there are basically 3 things you will get overview out of it. Okay, first one is this module will give you overview about BMS, BAS concepts, how the HVAC machines and equipments look like, few basic concepts regarding data analytics and how it makes a difference in the energy optimization. And then we will touch base a little bit about the MPC, which is called as a model predictive control. Okay, and this is in reference with the tagging philosophy or project Haystack. Okay, so just before starting, I just want to touch base very basic things. Okay, because when we talk about the EMS or energy management system, then few things we must know. Okay, and the first one is, if you see which industry we are talking about here. Okay, and if you ask me, let me take a pen. Okay, if you ask me which industry we are talking about, the HVAC industry is the name of the industry we are talking here. And then which segment, like what is the line of business we are talking about, right? So the commercial or domestic building segment, we generally called as. And when you called about the buildings, right? So what do you mean by buildings, right? And good example I will give you is a building in Burj Khalifa in Dubai, right? Or Empire State Building in US. Those are called as a big, tall buildings, or in general sense, we call it as a commercial buildings. The domestic building is something like your apartments or your residential houses. So that is a part of this building segment. Okay. Now, the most and the last important point here is what are the industry association we need to follow. Okay, if you're really interested into this topic, I recommended you guys to join these 2 organizations called as ASHRAE and ISHRAE. First one is American Society, and the next one is Indian Society. Okay, and you will get a lot of information about the updates in the new products, the industry standards, what are the white papers going on, what are the product development is happening. There are some very brilliant speakers who comes online and give some lectures on the webinar as well as in class trainings also. So there are a lot of information you can get it in these 2 association. Okay. So first question came in your mind, right? Why we are talking about, why we are utilizing our time to think about it. Okay. And the most and first important point you need to remember is we need to save energy and save water. And that belongs to sustainability, right? You always heard that in Antarctica and all, a lot of parts of the world, there is a sustainability campaign going on. The ice is melting, the snow is melting and all those, right? So the sustainability is the most important part. And that's why we have this SDG goals called as a sustainability development goals. Okay, and the whole goal of doing this energy management and saving water and all that, that belongs to less CO2 emission. Okay, because we want to save our planet, right? So that's most important. Less CO2 emission. We want to follow the SDG goals. We want to save energy. These are some primary goals. That's why we want to go there. Okay, and then next came about the business. This is about the first sentence about energy and all about the saving the planet. So the next one is, if you see the building management system, okay, and EMS is a part of it, I will say. if that is in 2016 is 6.65 billion, okay, and in 2023 or 2023 you will it going to reach around 19.25 billion, okay, with a CAGR of 16.71, okay. uh, so this is the enhancement, or this is the market we are going to capture. Okay, there are a few resources I have got this information, so you can follow this. Okay, the Tech Navio, this is another company which they also predict the same. So the business side for the job opportunities and all that, there is a huge demand. Okay, and that's why I encourage a lot of students who are joining this session to introduce yourself for this topic, and just you have great opportunity to learn here and do your career in this. Okay, so in the market dynamics, the drivers, okay, I'm not going to read everything, but increased demand for energy efficiency and eco-friendly buildings, and growing integration of IoT and machine learning. So computer science people, the guys who are working really great, because I heard yesterday there are some guys are talking about machine learning and all that, right? So there is a lot of good opportunities for us to go to the Internet of Things and machine learning into this area. Okay, what are the restraints? Okay, definitely there's a lack of technically skilled people, and that's why the ASHRAE and ISHRAE, they are encouraging and they educating the people to join more. Okay, and the R&D still, it's not catching up. The research and development, it's still not up to date. Okay, it's not up to mark, I will say. And the reason is a lot of researches are going on, like telecom industry and defense system, something like your Apple phone, right? So a lot of people are putting their R&D budgeting and all that in this industry, but there is a lot of chances for us to go and do the R&D into this area. Okay, definitely the opportunity is there, like integration of analytics and building management, growing demand for the emerging economies, but because lot of buildings owners and a lot of governments are asking for. Okay, and there are some challenges that we need to talk about. Okay. Next one is when we talk about building, and this is the picture I just took from the internet about the Burj Khalifa, right? This is a tall building, right? Around more than, I think, 130 number of floors are available. And if you see the Burj Khalifa with 828-meter, the height building. So these are the top 5 or top 6 tall commercial building in the world. And you can see Shanghai Tower in China, the Leto World in Korea, World Trade Center in the US. So these are all the big tall buildings. Okay, and why we are talking about this? Because for these tall buildings, we need some kind of air conditioning, and this is to do this air conditioning, we need a BMS system to control those equipments, those machines, right? Because in these buildings, the commercial buildings, there are some people are working, right? We need to keep them happy, keep them at comfortable level. So that's why we need to control them effectively, and for controlling the HVAC equipments and machines, we need BMS systems as well as EMS systems. Okay, if you see here on this left side picture, you can see the boilers, the chillers. Okay, then there are pumps, the air handling units, the terminal units, the diffusers and ducts, and there are a lot of mechanical equipments like cooling towers, as well as there are a lot of electrical things, a lot of thermodynamics also involved here. And for controllings, we need a lot of electronics engineer. For machine learning algorithms, we need a lot of computer science guys and all that. So as I said before, there is a lot of potential in this area, and we need to explore more. So this is the way generally the commercial building look like. Okay, and this is the floor by floor. For example, this is the first floor, this is second floor, this is the third floor, and then on the top there is a cooling tower. Okay, let's move to the next one. Now I'm going to show one video for you guys. Okay, and before going to that video, I just took the screenshot of this. Okay, and this is the name of my company. That's why I just highlighted here. Okay, if you see, there is a parking. So this, let's consider this is a small building. Okay, like kind of 3 floors here. Okay, and for these 3 floors, okay, you can see there is a kind of central equipment called as a chiller. Okay, and there are some pumps which are located here. Okay, and there are some air handling units which gives you the conditioned air to the floors, right? This air handling unit provides the conditioned air to the floors. And if you will see, there are some fan coil units which are also providing some of the conditioned air to these floors on the top. Okay, so there are the two air handling units. The air handling unit, the people who don't know the HVAC and all that, I just want to touch base very fast, but you need to do a Google and find out from your own what is mean by air handling unit, what you mean by the chill water system and all that. Okay, but most of the time, the chill water system or the chillers are producing the conditioned water or chill water to the building. Okay, and this conditioned water or chill water given to the air handling unit, and the air handling unit has some control valves as well as some pumps, okay, which distribute the water. And then when the cold water is passed through the coils, and then when you have blowers or the fan, it will get the cold air, or in the winter you can get the hot water also. Okay, you replace this chiller by the boilers. But this is the typical example in India, where you have the chillers, the pumps, the air handling units here, and the fan coil units. Okay, and then this is going to condition air to the system. Okay, and on the right side, I just highlighted these are the pumps, like primary pumps here. We just call it as the primary pumps because these pumps need to circulate water throughout the building. And then we have some of the chillers, some of the energy savings, because this is the most important for the sustainability. And then we will show some time. Okay, so in 1 minute, I just want to show you one video to entertain you. Okay. Start. Okay, and just take a look in the second round. I will show you how look like. So this is a kind of evening time. Okay, and the early morning. Okay, the moon is going down. Okay, and you can see there is a water flow going from the chillers. And when the morning started, the people starts coming in the office. Okay, the pumping started. The systems started loading up. You have two pumps now, three chillers, three pumps are getting activated. Okay, and as the evening started, so what is the time right now? It's around 2 o'clock in the afternoon. Okay, and when the time starts in the evening, you see the water flow starting lowering up, and you will see automatically the building load goes down. Okay, you can see the only in the water pumps and the chillers are going down. Okay, and it's evening or night time. Okay, and this is the way the building look like. Now the system again started, cycle again started. So you can see the moon here, right? So it's a night time. So 2 o'clock, 2 a.m. or 3 a.m. So there is no load in the building. Okay, there is nobody in the building. So that's why you have one chiller and one pump. And that's why the chiller is not producing water. But when it started, you can see the housekeeping guys started showing up. And then there is a demand, or there's a building load came up, and then you have the water distribution started. And when the water distribution started, your air handling unit starts running, and it's supplying the conditioned air to the floors and the space. Okay, and the people starts getting good. Okay, so this is good example of how the air conditioning works in a commercial building. So this is called as a centralized system. Okay, centralized air conditioning system. In big malls, in a cinema theaters, and big commercial buildings like offices, like Burj Khalifa, this kind of systems happen. You normally see a kind of small split systems or window AC in your home, right? So you can see, you can say that it's a bigger size than that. Okay, so this is called as a centralization AC. Okay, so let's close this. Go back to our presentation. So I think I covered a lot of basic concepts here. How the building look like, what is commercial building, what are the different equipments, what is EMS, what is BMS, and let's start talking about the building management system. Okay, so what do you mean by, what is the definition of building management system, right? It's a microprocessor based system which used to control, monitor, operation, and manage. Okay, so all these things has been done by a microprocessor based control system. Okay, and what we are controlling the HVAC equipments and machines, right? And what is the reason? We want to get the safe and comfortable working environment. Okay, your productivity will increase if you are good air conditioning at your home or your office. Your productivity will definitely increase. So that's why, and we are looking for the energy saving, as well as we are looking for reduction in time and cost. Okay, so generally in HVAC industry, what are the different equipments we are going to control, or we are going to talk? The air handling unit. Okay, this is the one example. The air handling unit produces the conditioned air. Okay, maybe hot air or the cold air, depending on the equipment, depending on the temperature, as well as on the environmental condition. The fan coil units and a small AHU, or you can say the split AC or window AC at your home. Okay, the chillers produces the chill water. Okay, these are the most highly energy consumers in the HVAC system, called as chillers. And there are a lot of research we need to do in the chillers. Okay, this is also costly equipments, and this consumes a lot of energy. Okay. The next one is the pumps for the circulation of the water to the system, to the whole building. The boilers are used most of the North America, like US, Canada, or maybe some of the European countries, because there is a super cold. Some part of Kashmir, Delhi, we also used boilers to keep the system a little bit hot in the winter season. And then VFDs, or called as the VSDs, used for the energy saving purpose. Okay, and there are a lot of more equipments like VAVs, the unit heater, exhaust fans, heat pumps, and we are not going to talk about that, but just want to give you
Hello, participants. We have some technical issues. Soon it will be resolved. Please bear with us.
Hello.
Yeah, carry on now, Vinay. Yeah.
Oh, okay. Can you see my screen
No, no.
now?
Yeah, yeah.
Yes, sir. Yeah.
Okay, sorry for that. I don't know what happened. I just
It's,
disconnected my wireless.
okay, it's okay, it's okay.
Okay.
And you can press that fly. Okay, fine.
Okay. So let's talk about very fast now component of BMS. Okay, there are three basic level of components of the BMS. The first one is called as the field devices, which kind of the sensors and valve and actuators which are connected to the controllers. Okay, kind of pressure sensors, the temperature and humidity sensors. The DDC controllers, kind of microprocessor based kind of PLCs you can call it as, but they are more specific for the used for the building automation or the HVAC industry. That's why they call it as a DDC or direct digital control. And something we called as the computer workstation or OWS, or kind of server where all the data has been saved or stored. Okay. So this is about, there is some graphics has been stored into the BMS server, and we need to save all the historical data like trends and alarms into that server. So the most important thing we need to remember that any DDC or any PLC controller, right? There is an input as well as there is output. Okay. So let me take a pen. So these are the things these called as a input, which with the blue ones, and the outputs are like you want to control the chiller or boiler or cooling towers, or you want to do control of the valves by using some electronic actuator. You can use the BSD or the pump fans or motors by using some REP relays or the electromagnetic relays. So this is typical things called as the free devices. Okay, and then what are the different features of the BMS? Okay, the man machine interface, you need to interact with the system. So generally the operator using generally the MMI or HMI. Okay, there is a login. You need to safely and securely log in into your system with the authorized people. There are some incident where the hacking has been happened through the BMS system. I just recently reading somewhere that in the Google Center, the users or the hackers using the BMS for the hacking their system. Okay, so it need to be very important for the system security. That's what the most of the computer engineers comes into the picture. The data presentation by using some of the graphics. Okay, and then there is a reporting also, means what time your system up and down, and what happened with your sensors, what happened to your chill water system and all that, as well as we need to do some data logging for the reporting. Okay. And the remote connectivity is very common nowadays. From here you can connect to US or any part of the world you can connect. You need internet to so that kind of BMS features need to be there. Okay. Then most important part of BMS feature is alarm management. Whatever the systems in an alarm, you need to give that alarms to the users as well as the operators. Then there is a time scheduling, there is event recording and all those important aspects. Time scheduling, something like what time you want to start your air handling unit, your equipments. Okay. Um, then there are some of the benefits. It can save a lot of manpowers and of labor hours can be saved. You can improve the comfort. So all those things. Most important, security and fire, right? So this is a part of a BMS. Okay, it's a separate entity, but has been integrated with the BMS. The unauthorized person cannot log in into the building and all that. Okay. During the fire, the most important part called as the smoke control. Okay, the smoke is most important part because of the smoke, a lot of people got killed, right? So to control that smoke control sequencing, BMS has a certain standards, okay, which is called as a smoke control, and that has been designed by UL Laboratories, United Laboratories. So there are a lot of different aspects. There is another term called as a stair pressurization. So whenever the fire happened, you're not allowed to use any lift or elevators, right, to go up and down in the building. So you need to use the stair. So in the staircase, we create some kind of pressure. Okay, we maintain some kind of pressure. So it will the fire or the smoke will not enter into the elevators or lift, into the stairs, and then the guys can walk from maybe from 12th floor to the basement and all that. Okay, and why we need BMS? As I mentioned before, we need to improve the environment quality. Okay, we need absolutely the energy savings. We need to faster response. If anything is emergency, we need to be quick in response. Okay, we need to have a consolidated facility control. There is a lot of things can be done through BMS there, so there is no need of manual intervention of the operator, so it's saving a lot of labor hours. Maintenance savings also, kind of predictive maintenance you can do by help of BMS and EMS. So this is generally look like the BMS software. Okay, and this is a pretty good example of the graphics, how it look like. You can see the temperatures across the chillers. So you can see there are 5 chillers running, 1, 2, 3, 4, 5, and what are the temperature the chiller has been producing and all that. So this is the way normally the graphics look like into the system. Okay, or HMI look like, kind of thing. Okay, and this is the programming to control correctly and optimally for the HVAC equipments and machines. We need BMS systems, and BMS systems has this software. Okay, there are kind of programming need to be done in either ladder programming or FVD, functional block programming, and all that. Okay, so in that case, we need a lot of good programmers like computer engineers or electronics engineers to this kind of programming. Okay, some of the screen capture about the EMS. Okay, and I already talked about what are the different field devices look like. Okay, and this is the most the important part of our discussion is like cloud-based solution, right? Nowadays we have changing the situation, because previously it was on-premise solution. Like in one building we have only the server, we have the controllers and everything. But nowadays we need to do a lot of data analytics. We do enterprise management and all that, and that's why we need your building management system has been connected to a cloud-based solution. Okay, so what are the advantage you are getting by this BMS cloud? You can get comprehensive view of the BMS. You can get a cost-effective synergy, security, and all those things you can get by using the cloud solution. Okay. Now we talk about a lot about HVAC system, right? HVAC control, but BMS scope is not only stick to HVAC control. It has a lot of things regarding lighting control. Like you have lights on top of your head. You have some dimmer sets. You can change the intensity of light, and you can save a lot of energy. So these are some of the areas where we have a lot of BMS scope, access control, the video security, like CCTV cameras, right, nowadays. So it can be integrated to the BMS system, and that is called as IBMS, Integrated Building Management System, because BMS is not only just to control the HVAC equipments or machines like AHUs and VAVs and all that. It has a lot of things consisting of electrical distribution, the renewable energies like wind energy or the solar energy and all that, right? So this is all about the BMS scope. Okay, and before going to the next topic, I just want to make sure that before going into the EMS or BMS, some of the basic concepts you need to make 100% sure that you understand that. And what you mean by basics is like what do you mean by DI or BI? Okay, like digital input or binary input. Okay, and what you mean by DO or BO, and what you mean by analog input, and what you mean by analog output. So what are these? These are the input and outputs connected to the controller, and according to that, we able to control any BMS system, any PLC system we can control. So these are a few concepts you need to make sure that you understand that, and then enter into the BMS area or EMS area for more investigation. The oil and gas industry, as well as any PLC, BMS, DDC automation, you need to understand all those, at least for these different configurations. Now I'm just going to talk you very high level on the let me take a time. Okay, on the BMS architecture, how it look like. Okay, so there are 3 levels of BMS architecture. Okay, the third one, which is called as a layer of DDC devices and sensors, and the actuators or the valves has been connected to that. And the second one, which is called as supervisory controllers, okay, which are taking care of all those DDCs. And on the top there is a server or computers, okay, for storing the data like history and trends. Okay, so all the DDCs has been providing all the data to the supervisory controllers, and supervisory controllers, providing data to the servers. Okay, and there are some of the MPC controllers from our Grundfos, they are connected here, and they can report directly to the supervisory or servers. Okay, so this is a BMS architecture commonly used in any building. Like if you ask me what are the BMS companies, Honeywell, Johnson Controls, Train, then Carroll, and there are a lot of different companies which are working on the BMS architecture. Okay, and this is very high level way of showing the controls engineering. What is the life cycle of this project? So starting from the cells, okay, going up to the project handover, these are the different phases. Okay, and the first one is like we need estimation engineers to find out how much the estimate of this building for controlling or for purchasing some of the equipments and all that. Then we need to design the hardware, for example, how many sensors and how many controllers we need. Then we need to go for the software programming, like what kind of SCADA programming you need, what kind of BMS programming we need, what kind of PLC programming you need. And then we move to the graphics programming, where it is used for the operators and all that. And then we do the field commissioning by looking all this. Okay. And then lastly, we do the project handover. So this is high level overview of the controls engineering lifecycle. Okay, and then question came, what is the difference between BMS and EMS, right? So the building management system, as I said, these are some of the companies they are using it. So it can BMS, sometimes some people call it as a BAS, some people call it as a BMS also. There is not a huge difference, but it can controls like HVAC, elevators, fire and safety. Okay. And BMS can control mechanical systems. Okay, so they can work efficiently together. But BAS is not 100% intelligence. Okay, there is no more intelligence into the BMS, and that's why the EMS we need to go companies like Coppertree and all those. Okay, because in energy management system it measures the energy expenditure and then identify the energy saving opportunities into that. Okay, and then the energy management system recalibrates and streamline the building energy, okay, without necessitating any invisible installation. So there is no need of putting any costly installation into the building. Okay, in general sense, by using some of the recalibrations or using some of the easy used equipments and some of the data, we can definitely save some energy. Again, we can save some installation also. Okay. And the last one is what EMS is opposite to BMS. It continuously monitors your building performance and energy consumption. So as I mentioned, okay, it measures the energy expenditures. Okay, and I'm going to show you how the Coppertree do that. Okay, so it measures the energy consumption and it measures against the optimal performance guidelines. Okay, and there is a baseline also, and when we compare all that, then definitely we are going to see some of the savings in the energy. Okay, so let's talk about the first most important part, which is called as the CPO. Okay, and this is related to the chillers. Okay, some people call it as a center plant optimizer, some people call it as a chiller plant optimizer also. Okay, so what you mean by optimization, right? We want to save the energy, that is very sure, but the big central plants or chiller plants, they have the chillers and the pumps and the cooling towers, like big HVAC equipments, and we need to produce or provide some of the algorithms, some of the controls logic. Okay, so in that way it can be performed in a high or at peak as well as it can be save a lot of energy. Okay, in old days, there is a not more concentration on the energy saving, but nowadays, because we are going with a sustainability issue, we want to save energy, and it's something we say, like if you save a penny or save a 1 rupee, we earn a 1 rupee kind of things. Okay, so we want to save every penny, every 1 rupee for the energy consumption. Okay. The central plant optimizer is an algorithm, okay, and there are a lot of machine learning that also comes into the picture nowadays. But it is used for the energy optimization in the HVAC system, and generally it's related to the chill water system. Okay. So as I mentioned before, what are the main components of the HVAC system? Just want to brush it up once again: the boilers, the chillers, the air handling units, and some of the VAVs. Okay, and the cooling towers also. These are some of the important parts of HVAC system. Okay, and this is some of the examples how the big chiller plant look like. And if you see here, there is a electric chillers, there is a heat recovery chillers, there is a thermo storage tank. Okay, there is a boilers, there's hot water boilers, hot water generators, there is a cooling towers, and there is also heat exchangers and all that. Okay, so this is the way generally the central plant look like. And what generally we do, this is another representation of that, like a perspective view or top view. You can see the heat recovery chillers, kind of chillers which produce the hot water as well as the chill water. Okay, and what we are doing, okay, by using some of the algorithms, okay, we want to save the energy. Okay, and one example I will show you here is, the thermo storage tanks. They are generally used kind of big tanks of the water storage. Okay, in the night time, generally the energy rates or the energy demand rates are really less. Okay, so in the daytime, okay, we can in the night time we can store all the cold water or the hot water into this thermal storage tank. Okay, because in the night time the energy rates are really less, and in the daytime we can just utilize this water from this thermal storage to give the water to the building. Okay, so here is the building. So we can in the daytime just open the valves, or maybe we can start some pumps and then just circulate water from this cold thermal storage tank to the building. So in that way we save energy. Okay, so these are some of the examples. Okay, so the chill water plant optimization, right? What are the different numbers you need to mention? So there is a kW per ton, which is a common kind of measure, or another term called as a COP, coefficient of performance, has been used in the industry as well as in building for measuring the performance of chill water system as well as for the chillers. Okay, so the 0.5 kW per ton is very common number, and I'm encouraging the guys who are here, okay, who can work on the chill water plant. And there are some intelligent algorithms like MPC and machine learning where we can produce some kind of controls. So the kW per ton, we can get it like 0.5. Okay, if there is no 0.5 we are getting, like if we are getting like 1.0, okay, then we need an improvement. Okay, we need to find out those buildings and then most of the old chiller plants. Okay, and we need to get it like around 0.5. What you mean by kW per ton is kind of ton or tonnage. Okay, is the unit of refrigeration, and kW is the unit of the electricity, right? So how much of electricity you are going to provide in spite of in relation how many of tons of refrigeration you are going to produce. So that's the measure. That's why it's called as a kW per ton. COP is nothing but kW per ton, but it's in the reverse. Okay, most of the industries, maybe in US, they are using COP as kind of phenomenon or kind of parameter. Okay. So why I'm talking about this, because there are a lot of MNCs are working on that. For example, Johnson Control Metas CPO. They are working on this center plant optimization terminology or techniques. Then Optimum Energy and another company, they are using this Hartmann loop, okay, for doing this. And there's a model predictive control also came into the picture, because MPC is the technique used in the oil and gas industry from so many years, and now it entered into the BMS world. Okay. There is also some of the other companies like United Technologies, ALC. Okay, some people are going for the patent applications also. Okay, so not only we have chance about the controlling and all that, we have some patent applications you can file. Okay, and you can create some research into that region also. Okay, and there is another company, Siemens, will going with the design flow also. Okay, so what do you mean by center plant optimization? Okay, it's an application, it's energy efficient components. Okay, no, it's not like that. What is reality? It's a process. Okay, and these are the some of the layers of the process, like design of system infrastructure, selection of system components, application of components, and all that. Okay, so all those around 7 layers has been mentioned here. Okay, and there are some of the detailing I have given here. Okay, for example, if your system need to be adding some of the VSDs for the chillers and pumps, you need to do that. Okay, because the VSDs are used for the energy savings, and so this is the optimization step number 1. Okay, so you need to put the VFDs or VSDs to the systems. Okay, you need to select a component which will give some kind of energy savings, like some of the selection of the components, like you need to use some of the chillers and all that. Okay, the third one is about application of components. Okay, so if plant was designed to run at 45 degrees, okay, running at 42 degrees will reduce the optimization potential because you're reducing by 2 degrees. Okay, and when you reduced by 2 degrees, the chiller will not too much loaded, and we can save some energy. Okay, the automation of the system, and that's why the BAS and BMS comes into the picture, where we can do a lot of detailing. Okay. I'm just going fast here because a lot of data and a lot of information is available. Okay, you need to do networking of the optimization software. Okay, maintenance also, because you need to check thoroughly and regularly how your system is performance by measuring the kW per ton and all that. Okay, and the MNV, which is called as a measurement and verification. Okay, so not only you installed and finished, you need to do the MNV every year, every 6 months, every 3 months, how your system is working, how much kW per ton you are getting, are your chillers working efficiently as per the design condition, your pumps are running as per your design condition, you need to find out that. Okay, and this is the good example how the CPO look like. Okay, there is a chill water system. Okay, and there are some of the controllers like supervisory controllers where the BMS system resides, and there are some of the other intelligent CPO. You can add it. Okay, which is connected to the BMS controllers, and you can connect it to the internet, or where you can do the MNV logic. Okay, some kind of machine learning. You can write it down in this box, and then it will given the data to the optimizer, and then optimizer can give it commands to the BMS to control the optimally chillers and VSDs and all that. Okay, but we need the sensor data. So the data from the sensors, from the VFDs, from the chillers has been passed to the BMS, and from the BMS is passed to the kind of Raspberry Pi or kind of microcontroller. And from that microcontroller, the data has been connected through cloud to the server, to the cloud server. And then there are some intelligent algorithms are running, which will control the whole optimization sequence. Okay, and this is the some of the um, dashboards I'm showing you today. Like you can see the kW per ton, how the poor, the fair, and all that. Okay, and you can see the bidding information and all that. What is the CO2 saving, right? The carbon dioxide saving we are talking about, and how much of energy you are saving, how much of money you are saving. That is also shown here, and the kWh, kilowatt hour savings and all that. So all these things are most important for the facility people. Okay. There are some patents I have studied, and the information I have mentioned here. So there is no need of going into that. But there are some concepts they are talking about. If you increase the temperature, or you can say increase the temperature set point for some degrees, and if you lower some of the condenser water supply temperature, you can save some energy. So this is what they are mentioned here. So I just want to give you different companies, different areas of interest, how they are going. So this is the ALC patent from the United Technologies. They are talking about it. Okay, and these Google patents are available. If you put the Google patent in the Google, then you can get all the information about this patent. And if you found out this number of the patent, you can get all the information what they are talking about. Okay, so everything is available on the internet. So this is the demand flow, and this is Siemens kind of optimization software, I think. Okay, and demand flow, they are talking about how you can do the kW per ton and all that. Okay, so there are some of the information they have given how you can do the optimization and all that. Okay. And as I mentioned, the chill water system is number one in the energy consumption. The chill water pump and the condensed water pump, as well as cooling towers also, and then air handling unit fan or the blower also, doing some of the energy consumption in the commercial building. Some of the benefits, how we can use it and all that. So these are from Siemens, where they are doing it. Okay, and in the demand flow, they're mentioning what are the things you need to do, you need to consider for saving the energy and all that. Put the VFDs on the chill water side and pumps and cooling towers and all that. Okay, so these are some of the information. Okay, so more on the chillers, there is a concept called as a lift. Okay, so how you can manage the lift and how you can save the energy. Okay. There is statistical energy modeling. So some of the regression, some of the statistical energy modeling we need to do to find out the energy optimization techniques. So this is the annual KW profile. So each like day of the year, if you see 365 days, how your chiller is performing. Maybe in the middle there is a summer season. That's why it's producing a lot of KW. So this kind of profiles you can create in MATLAB and all the simulation software, and you can do the energy optimization. Okay, so the MPC and machine learning, these are the new things came into the EMS software. Okay, and what is their main goal? To minimize the cost. Okay, and to minimize the cost, they are using not only the data which is coming from the building, also they are using the time horizon or kind of historical data. Okay, what has happened with your building in last couple of years. So they are doing all those calculations and using for the optimization purpose. So there are a lot of text, so I'm not going to read into that, but I will show you an important diagram here. Okay, so if you see here, there is a cold thermal storage water tank, there is a hot water thermal storage tank, there is a cooling towers, there are chillers. Okay, there is heat recovery chillers, and this is the gas, this is the water, and this is the electricity. Okay, so what generally happened is in the MPC, okay, it goes into the high level optimization, and there is concept of a low level optimization, and looking all those parameters in the MPC, it will calculate which is the best and efficient plant, or which is the best and efficient equipment to run during the season like summer or winter. Okay, for example, in the winter, you can start with the heat recovery chiller because it will produce the hot water as well as produce the cold water. Okay, so in spite of starting the chillers for the winter season, because most of the time chillers needed in the winter season for the data centers or the computer rooms, like crack rooms we call it as, like your servers need to be always cooled down, right? So that's why we need chillers. So in spite of starting the electrical chillers, you can start the heat recovery chillers. Okay, and this is the good example of how the MPC work. Okay, for the basic things needed for the MPC, okay, which is called as a predictive cost optimization, you need the weather forecast. Okay, you need to tie up with the weather station where you can get the weather data. You need to load prediction. Okay, the load is like building load. Okay, like cooling load, heating load, the electrical load in your building. You need utility pricing prediction also. What are the utility pricing going to be there? What are the charges for the electricity kind of electric energy, okay, or for the powers, okay, electrical power, and what is your calendars and maintenance schedule, okay, and some of the mathematical foundation. Okay, so all those if integrated together, and this is what we given to the MPC, and then the MPC gives the information, okay, how and which equipments you need to start and which equipments you need to stop. Okay, and then you will get definitely the energy saving. In old days, generally, we start the chillers or we start the pumps on the runtime basis. Okay, but this is not the case in today's world. Okay, by looking the weather data, by looking the load prediction of electricity, by looking the utility pricing, the calendar and maintenance schedule, or the adaptive equipment models, kind of load profiles of your pumps, of your chillers and boilers. When all those has been given to some of kind of maths, which is a model predictive control, then it will give optimal control of your particular equipments and your building. Okay, so HVAC is not only MPC, or it's not only stick to chill water plant. Okay, there are a lot of different things and a lot of different opportunities, like optimizing the fan, the pump, the balancing, rebalancing water distribution system. Okay, addressing the duct sealing and leakages, optimizing the boilers and water heater system, the demand response system, using occupancy control for the control HVAC. So I will give you an example of your shopping center, right? In a shopping center, depending on the people entering, you can control the air conditioning of that particular shopping center. Okay, and there is a free cooling or water side economizer. For example, if you have cold outside, most of the US and most of the countries in North America, right, or Europe, there is always free cooling available. Cold air is available, so we can use that cold air without igniting the cooling coil, and without igniting the chillers. We can use this cold coil or the cold air into the building. Okay, used for the air conditioning, for something like your computer rooms and all that. More than that, there are a lot of different strategies you need to remember. How we can utilize the outdoor air temperature, how we can utilize the night setback mode. Okay, when in the night setback, when there is a nobody in the building, how we can keep the system or your building running, keep in good condition, warm and all that. Okay, and how we can do the calculations of the energy, how we can do the electricity consumption cost as well as demand cost. Okay, so there are a lot of information is available and a lot of research is going on in North America. Okay, so we need to from India, we need to enter into this area. Okay, so I like this picture. Okay, because what happened in number of times that we have the good energy management. So this is, I will say, EMS, energy management. Okay, but a lot of people, they are not thinking, we don't need any intelligent system. We are happy with our old, like square kind of wheel. Okay, so EMS is like that. It will help to reduce your energy expenditure and all that. So if you see this graphs here, okay, and why I took this graphs, because building use more than 38% of all US energy. Okay, and that's why a lot of research is going on regarding this energy consumption and all that. Okay, so you can see the 35% for the commercial and the industrial HVAC for 3%, and the residential for 37%. So there are a lot of scope and opportunities for do the research, and we can go for the optimization purpose. Okay, so we want to increase the energy efficiency, improve the tenant comfort. We want to reduce the maintenance, and we want to prolong the equipment life. Okay, because we don't want our chiller or our air handling unit to break on the other day, right? Or the next day. So we want to make sure that they will live longer. Okay, there is not like they will live for 1 year or maybe for 2-3 years. That's why we need to consider all this analytics and all that. Okay. Now let's talk about the project haystack. So project haystack, and you can just Google this, or you can use this website here. Okay, because it's the data which is available in the building. Okay, which is not a streamline. It's kind of abrupt of data. It's not a correct shaped and size data. Okay, and that's why some of the guys from the building management and HVAC industry came and they made the community called as a project haystack. Okay, and this is linked to the Internet of Things. Okay, because a lot of energy analysis, lot of data analysis, lot of energy reduction, lot of lighting, you need to get the data in correct format. Okay, and that's why the project haystack coming with some kind of tagging philosophy. Okay, and that's why, we need to tag a particular point. Okay, as I mentioned, there are AI, BI, analog inputs, binary inputs to the controllers, and we need to tag those points. And if we tag those points, we can do the energy analysis and all that. Okay, so this is the good example I like to give you. Any school, hospital, or any office, any shopping center, it has maximum, or sorry, it's a minimum of 2000 points. Okay, and maximum maybe 1 lakh, 2 lakhs, or whatever you can count. Okay, so what generally happened is this data is something like a raw or clay. Okay, and if you see this picture, okay, from this raw data, we need to make some kind of beautiful pots or beautiful bottles, right? This is what this is analytics do. It find out the data, it connects the data, it store the data, it analyze the data, and then make some action. And this action is like this. Okay, and this is what the whole and goal of an EMS. We have a lot of data. Okay, and we don't know what is this data. Okay, in a building, commercial building, there's a lot of data is available. So if we convert that data in good format, okay, and we do some analysis out of it, and we can say like, there is a Christmas going on, or there is a Diwali going on. So we don't want to keep the building running 24/7. Okay, or there is nobody in the school or office. Okay, we want to shut down the whole system, or we can shut down to the minimum level. Okay, then we can save a lot of energy. And this is what data analytics all about. Okay, there is an example of project haystack, and there is another example. I just want to give you a brick schema. A brick schema is another community, same like project haystack. Okay, so any particular box, like VAV box. Okay, generally the VAV box has been served by some of the air handling unit. Okay, so AHU is serving to the VAV box. Okay, a VAV box is nothing but a small device for the air circulation. Okay, so and one AHU maybe have 100 VAV boxes like this. Okay, so if we find out the relationship between the AHU and VAV, okay, by using some project haystack, then we can do some kind of algorithms, intelligent algorithms, which will save the energy for the AHU as well as save the energy for the VAVs. And we can do the intelligent alarming also. For example, if suppose there is a chillers, okay, there is a chillers is connected to the AHU, and AHU is connected to the VAVs, right? And suppose the chiller has been broken, right? Chiller is not working fine. So the AHU is also not working fine. And because of that, the VAV is also not working fine. But in current BMS system, we have individual alarms for VAV, we have individual alarms for AHU, and then for the chillers. So it's like a bombarding of alarms. Like there are like 1,000 alarms for the operators, okay, or for the building owners, and he don't want to see those 100 alarms. Okay, the main reason the chiller is in alarm or chiller is broken, that's why there is alarms. So there is no need of going VAVs into alarm mode and all that. Okay, if you found out the chiller are not working fine, then we can we can clear these things, and then there is no need of going into the detail about the AHUs and VAVs. Okay, so the root cause analysis and all that you can done by using the project haystack and all that. Okay, and to get the data, you need to find out what is the sensor. Is this, for example, this is example like this point name is AHU1 supplier temperature. Okay, and then it talk about the sensor, the temperature, what is the degree Fahrenheit and all that. Okay, so this is the beauty of the project haystack. Okay, and in for any point in the project haystack, you can find out a lot of different information about this. Okay, there are a lot of information about project haystack. They are using Niagara from, they're using REST API and all that. You can find out on project haystack website. Okay, and you can see this is a good example of the chill water system. This is the way it graphics look like. Okay, and the example which I mentioned you before, that will give the example, gives you scenario how we can solve the challenge. Okay, and I came to the last topic, okay, because I think I already over time, but I will finish in 10 minutes. The Copper Tree, because this is my current project which I'm working. So Copper Tree is the name of the organization, okay, and how they are doing the data analytics, I'm going to show you. Okay, so they are using the software called as a Kaizen, okay, and there is a lot of computer programming like Java, Python, and all that. Okay, but this is the UI of the dashboard kind of software Kaizen. Okay, and this is a patented software, okay, which I'm going to show you. And as I said, Copper Tree came from the data controls, which they started as a controls company in 1980, and they came into the analytics in 2018. Okay, and I'm not going to talk about all these things about their marketing campaign, but these are some of the challenges in commercial building. The HVAC systems are complex to design. Okay, there is a maintenance liabilities, there is some rebates, there is a data is difficult to extract from the building, and that's why we said we are using Project Haystack. And Copper Tree using Project Haystack, for capturing the data. Okay, the energy and maintenance are expensive, the facilities and people are understaffed. There is always a crunch on the labors, right? And we want to do the savings on the energy. That's most important. Well, if you save the energy of the building, you will get some incentives and all that. Okay. So this is what the 39% of North America and all that. This is the expenditure of the what is happening and all that. Okay, I'm not going into detail into that. Just I want to show you what they are doing is they are increasing the energy efficiency. They are improving the occupant comfort, reducing the maintenance cost, and they change, like they are using the equipment should run for the more time. Okay. So these are the steps which I told you before. They acquire the data, they analyze the data, they do the prioritization of the data, and then they do M&V, measuring and verification of the data. Okay. So if you see here, okay, they have some kind of Raspberry Pi, or they call it the edge device. So this is your BMS system, okay, which is controlling the chillers, the boilers, air handling units, elevators, and all that. So all the data has been fetched from the Copper Tree edge device, and this edge device will send the data through the internet, and you can see the weather station also integrated to their algorithm. Okay, and there are a lot of machine learning algorithm they have written, and they have this analytical server, okay, where they do this calculation, and then they give kind of advisory, okay, to the BMS that this is going too much, this is going too high, and all that. Okay, and then they can send the alerts and reports and on your mobile and PC. Okay, so this is what the whole architecture look like. Your BMS connected to the edge device or kind of microcontroller device, and the microcontroller device is connected through the internet to the Kaizen, to the analytical software. Okay, and the weather station also integrated here. Okay, so FDD and Kaizen Energy. So these are the two softwares they are using. FDD, you can see the dashboard. So I'm going to show you that. And then the Kaizen Energy, it will give the portfolio information about about your water, gas, and all those information. Okay, so just want to make sure, if you count 30 data points for the air handling unit, okay, we put a trends for those data points, and then we get around 31 lakhs 53,600 samples. Okay, and for that one AHU, if you see this much of samples, if you have 10 AHUs, how much of data, right? So this is another direction we are going into the big data. Okay, because you have a lot of data you need to collect and analyze. Okay, and if you see, these are the samples you need to take it, and you need to make some analysis on those samples. Okay, and this is a good example. Most of the BMS system, they're not able to find out this kind of faults, because they think the people who are sitting on the floor, okay, they think everything is working good, they not feel any discomfort, but at the back side there is something is happening, which is a leaking damper. Okay, so operator thinks everything is working fine, occupants has no complaint, the BMS guys are happy because there is no complaint, there is no BMS alarm triggering, and this is but at the end of the day you get the high electricity bill. The building owner, maybe he dead after looking. So to save this kind of expenditure, we need companies like Copper Tree, and there are a lot of companies, like there are more than 1,000 companies in the world which working on this energy management and all that. Okay, this is another example of how the economical sequence look like. And this is the information about how they are using the machine learning and all that. Okay, so I'm not going into that. One thing I want to mention about the BMS, that BMS has always a limitation on object count. Okay, so they avoid trending of few points. Okay, there is always limitation on the object count, and that's why they're not able to write some of the intelligent coding. So BMS also can work as a EMS, but BMS has some limitation on the controller side. Okay, and that's why they need. Okay, and these are some of the FDD in Kaizen energy. What are the different gaps left by BMS and how they can solve it? Okay, these are some information. And I think that this is the last slide, and I will say thank you. But before going to that, I just want to show very high level 1 minute pitch on how the demo look, the actual site, the EMS site look like. So this is the copper tree site, if you see, and this is the Kaizen, the name of the software, and this is the building I'm going to see. So this is again a demo site, if you can see here. Okay, this is the demo site. Okay, so nothing practical building, but I want to show you how look like. So this is the building, the picture of the building. This is kind of building address, and this is the location, and you can see what are the different faults in a building, what are the different fault detection, what are the energy saving opportunities. There are some golden standard kind of if the system is not working fine and all that. Okay, so if you go to the fault, so there are dashboard we are looking. Okay, there is a vault. Okay, like what are the points or trending points you can find out. Okay, what are the insights, like your AHU cooling coil is not working properly, so this is the alarm. Okay, what are the energy things, some kind of meters you can show or you can add. Okay, you can see how your air handling unit, the kWh is going up and down, so you can find out by looking in this picture. Okay, you can generate reports, what is different KPIs. Okay, some of the regression analysis you can generate, some of the charts you can find out by looking this one. Let me see whether I am able to see very quickly some of the charts. Okay, you can find out. Okay, so let's go to the dashboard. Okay, so if you see the dashboard, this is a potential savings of around 20,000 US dollars per year. You can get it. Okay, so this is the potential saving. Like if your equipment's working in a fine condition, in good condition, then you can save kind of 20,000 USD per year. Okay, so this shows that the equipments are not working fine. And what is the condition? If you see, the boiler B3 has been operating while the outdoor air temperature is above lockdown temperature or lockout temperature. So there are some of the information, okay, which we need to correlate, and then we can find out by using some mathematical formula like affinity laws, some of the basic calculations. You can find out what are the different savings per year. Like if you see AHU 10 supply energy consumption is beyond baseline. Okay, so maybe the fan is running too much, okay, more than its occupancy schedule. Okay, and you can see the different impacts like your energy comfort impact and all that. Okay, but let's go to the section, one window here. Okay, and you can see this different alarms came up, different conditions came up, and that belongs to the potential savings. Okay, you can go and see some kind of rules, working rules here. Okay, and you can see some of the graphs, how this look like and all that. Okay. So this is about a Kaizen. This is a copper trees Kaizen. Okay, and another one I want to show you. This is the last topic. The Kaizen energy. Yeah, this is the Kaizen energy. Okay, and what is Kaizen energy is more on the okay, more on the portfolio level. Okay, for example, how much is your water, how much your gas, that information, because basically for any enterprise level, you need these kind of different things. Like you can see what is the electricity consumption, and if you go in detail, okay, it will give the information about how it's performing, maybe in day out. Okay, what is your consumption versus baseline calculations, what is the different layers, like your faculty, your community building and all that. Okay, in 2018 how it looked like, and you can compare that with 2019. Okay, with a particular month you can go and track down to like March what happened. So this is the main spring city portfolio energy consumption. So this is most important things that most of the facility managers want to see. Okay, so this is all about the Kaizen energy. Okay, so I think that's it. Thanks for watching, and let me go back here. Okay, and
Vinay, hi
yeah,
Vinay. Hi
yeah,
Vinay,
any
thanks for
question?
your detailed presentation and very highly informative session. We have few questions here. The
Yes.
first question is from Shivaranjani, Madam. The question is, in what way modern predictive control provide better control over other conventional control schemes?
Okay, so as I mentioned before, the MPC has four, because MPC, definitely there is some kind of data you need to feed in, right? And that data is like weather data or electricity data and all that, right? So all that data, if you provide it to the MPC, okay, and it has the energy optimization sub kind of subroutine, okay, in MPC, that will do some mathematical calculations, and according to that mathematical calculations, we will figure it out which piece of equipment or which piece of kind of plant, chill water plant or hot water plant, you can start and stop. Okay, the other simple control algorithm like pit loop, PID loop, which is a conventional methods, okay, they are not stick to anything like weather data or energy rate or building load. Okay, this is not about prediction. They are just a conventional control system which we are using like from last 20-30 years. Okay, the MPC, and moving ahead to the machine learning. Okay, that is another part. They are taking care of all the maximum maintenance schedule, your calendar data, like you have holidays, your equipment going to be down, and all those has been integrated, written some intelligent algorithms, and there are some patented algorithms which do all the maths, and then it will find out which is the best way to control your plant, your equipments, and your machines. There is there is a mass energy also, and the MPC is not stick to only chiller plant. The most of the big players, their R&D departments are going into the air handling units, okay, the VAVs, and on the air side also. So it's good that it's more more than the conventional way, using all the data from the weather station, the energy and all that. Okay, this is the biggest difference. They are not using any conventional. They are not conventional systems not using any prediction data about the weather station and all that. Thank you.
Madam, hope your question is answered, Madam. And Vinay, we have one more question here. What metrics are chosen for analyzing faults using machine learning?
Okay. Exactly, I can't give the answer of this question. Okay, for the fault finding, basically the old conventional method, is as I mentioned you, like if the VAV is off, right, VAV is not working fine. Okay, it just generate alarm in a normal BMS system. Okay, but in a machine learning or maybe in a MPC, okay, or moving ahead to the copper tree guys, okay, what they are looking the kind of common data, okay, or some people call it as a common data model. For example, the VAV has been connected to the AHU, right, and the AHU has been connected to chillers. So if they look holistically with what are the different systems are connected to each other, okay, and they do some kind of logical relationship between each other, then you can find out what is the correct way of finding the fault. The old conventional method, if the fan failed, we generate alarms because I commission number of systems. Oh, okay. So if the supply fan failed for the air handling unit, just generate alarm. But it's not, we are not going stick to the old conventional method. What we want to do is we want to integrate the fault with help of the VFDs, because most of the HU supply fan has been controlled, has been connected by the VFD or VSD. And if we find out from the VFD, okay, what is the right way, okay, what happened exactly, it's not a bait alarm, it's not the blower alarm, it's because of VFD goes into alarm. Okay, so all this integration, all these things need to be linked to each other, and then you can do an intelligent alarm. Okay, so this is kind of overcome or kind of one step ahead of all the old alarm methods. So the CDM, if you search on the Google, maybe you will, and the good example is brick schema. Okay, if you make note of it, brick schema, where you can find out this intelligent alarming, how it works in the advanced methods of tagging and machine learning going ahead. Okay, thank you. You there, ma'am?
Thank you, Vinay. Thank you, Vinay. Thank you, Vinay. Now, I request Padmavati ma'am to propose vote of thanks. Padmavati ma'am.
Good evening, everyone. I would like to thank our today's chief guest, Mr. Vinay sir, for taking his precious time out and consenting to be the chief guest for this FDP. Thank you, sir, for your highly informative and valuable session regarding the energy management system. Thank you so much. I would like to thank our management team, respected principal sir and HOD sir, for providing the continuous support for organizing this kind of event. Thank you. And last but not least, I would like to thank all the participants for showing their interest for joining this FDP. Thank you.
Yes, and last request, if there are more questions, I know there are a lot of questions coming up. Madam, you can collect that and send it to me.
Only 2 questions they have posted. I hope they are very clear what you have explained. They are very clear about what you have explained. If at all, if any question arises, I request the participants to share it in the mail ID so that it will be posted to our today's session speaker. Hope you had a useful session today. Participants will meet you tomorrow, same time. Vinay, I thank once again Vinay for accepting our request and sharing his valuable experience with our participants to know what is happening in the energy management systems or building management systems. Thank you again, Vinay, once again for such a wonderful session. See you again for another course of webinar soon. Thank you.
Thank you. Thanks, ma'am. Thanks, everybody.
Vinay sir, thank you so much for accepting your invitation and delivering wonderful presentation. Hope we meet soon. Thank you so much, sir.
Yes. I can share this presentation with you, ma'am. Then you can circulate if you want.
Sure. Definitely. I'll share that to the participants' mail.
Okay. Thank you. Bye.
Thank you, Vinay. See you. Bye.